All right, the next step in this section is to learn about how to solve for a matrix equation if there's multiplication going on between two matrices or between the matrix and x. So to undo the matrix multiplication, we never, ever, ever divide. There is no division of matrices. Instead, it goes back to like if we wanted to move sign to the other side, we're going to use the inverse. So that's why we learned how to do this over the last 2 lessons, both by hand and then when we got to 3x3s by the calculator. So if you look at the first just general equation, we would want to solve for x. So we would want to get at the x by itself. So we're going to have to get rid of the a. To move that to the other side, this is again, you need to know you can't divide, we have to use the inverse. But there is a specific order that you have to do this in. So you have to insert that in front on the left-hand side to get it next to the a. They have to be next to each other to get it to cancel, which means you also have to put it in front on the right-hand side. So that's just the really important thing. I kind of need you to get in your head that you have to do a inverse b, that the inverse always ends up in front. So the solution here to get x, the a and the inverse cancel each other out. You just get the identity, and then that equals a inverse b. So we're going to try number 1. Sometimes I find it easier just to label which one's a and b. A is going to be the one with x, b is the one that's by itself. And now to get x by itself, I need to think about what I need to do to move the A matrix to the other side. So to move the A matrix to the other side, I'm going to have to use its inverse. And remember I talked about the fact that that would need to go first in front. So it's going to be the inverse of A times B. Let's just talk for a quick second about why the inverse has to go in front. Look at the dimensions of these two right now. This one's a 2x2, and this one's a 2x1. Think about what would happen if I actually put the inverse at the end instead of the beginning. The dimensions actually wouldn't work. So that's why that A inverse, that has to go in front for you to get it to work out so you can get an answer. So then we're just going to type it in the calculator. You could, if you wanted to, multiply by hand, but you can just use your calculator since I taught you that yesterday. And now to the left, you can see what you get when you type that in your calculator. You get -8, 9. And just to think for a second, what that gives us is if I took that answer for x and I plugged it back in here, and I did the multiplication of a times x, the answer ends up being b. Just look at the top row times the column. You get -32 plus 27, which gives you -5. And if we did the bottom row real quick, it'd be -16 plus 18, which gives you +2. So we're finding that matrix that would need to go there to get the answer for B. All right, on the next page, you just need to be careful about which one you're trying to get rid of. So I'm trying always to get the x by itself, so that should be your focus. If I want to get x by itself, this one next to the x is the one that I need to move to the other side. So that one is going to go first, and to move it to the other side, I have to use the inverse. So it's going to be the inverse of that one times the one that was already there. And then that's what you need to type in your calculator to get the answer. And from the calculator, you can see that the answer for the x matrix is -14, 20, 19, 28. Okay? All right, for number 3, we just have multiple operations here. So you really got to put on your thinking cap of what you're going to do to get that x by itself. You have to undo the operations in the correct order. So right now, there's something being multiplied by x, and there's something being subtracted from x. The subtraction is the one that we want to move first. So our first step is actually to move this to the other side. To move it, since it's being subtracted, we just add it to the other side. We're doing the opposite operation. So this is going to get added over here. Now, if you want to, you can type that in your calculator. It's honestly less work to just add it by hand. So this is going to be 21. This is going to be 56, 35, -12, -31, and -11. And then the other matrix that was left is going to come down with x. And then we need to think about, again, our goal is to get the x by itself. To get the x by itself, I have to undo that matrix that's being multiplied to undo multiplication. we're going to use the inverse. So this one's moving to this side, and again, the inverse always goes in front. So that's going to be -7, 4, 3 to the -1 times 21, 56, 35, -12, -31, -11. So I just typed it in the calculator, and according to the calculator, the answer for x is -3, 7, 4, 0, -1, -9. Okay. All right, the one other thing we're going to look at is how to solve a system using matrices. So this actually takes us back to, if you remember, in third quarter we did solving 3 variable systems by hand, where we had problems that took up nearly an entire page just with the number of substitution steps we needed to do and elimination steps just to get things to cancel. So this is an alternative method to doing that actually allows your calculator to do all of the work, is we can take the system and turn it into a set of matrices. So that's the first thing I'm going to teach you how to do. The first matrix is what's called the coefficient matrix. Oops. The coefficient matrix just lists out all the coefficients on the side with the variables. So you do have to make sure that these are in standard form first, but then you can plug in these coefficients. The next matrix is the variable matrix, which is where we put the variables. But what you have to do in order to get the system that we have up at the top is you have to make sure that you put the variable matrix as a column. So x and y would go in a column, because now if you look for a second, if we were to multiply the top row by that column, we would get 1x plus 2y. If we did the bottom row times the column, we'd get 4x plus 5y. And then the last one is the constant matrix. This is where you put the answers from the other side. We get 3 and 6. Okay? So that's just the basics of setting it up. Now we're going to talk about setting it up and then actually solving for the variables. So first thing we have to do in number 1 is we actually have to get everything lined up nicely like that first example was. So I'm going to move this 2b over to the other side. I'm going to add it over there so everything lines up nicely. So the first one's 5a plus 3b equals 7 still, but this one changes to 3a plus 2b equals 5. And then we need to set up our matrices. So again, the coefficient matrix you get from plucking all the coefficients off of the variables. And then your variable matrix is always next as a column. So this is going to be A and B in whatever order they're currently in. And then that's going to be equal to the constant matrix, which is 7 and 5. And then we just solve this like we learned on the last page, is we need to think about what we can do to move the blue matrix to the other side so we can get the AB by itself. Because those are being multiplied, to move it, I have to use the inverse. So to find AB, I'm going to do the inverse of that matrix times 7, 5. And then we're just going to type that in the calculator to get the answer. So then out of the calculator, you should get that the AB matrix is equal to -1, 4. And we're just going to go back to how we wrote the answers for this when we were solving systems. We're going to change that to an ordered pair here. So it's -1, 4. Okay, let's try one more. So we just got one more to try here. So my first step is going to be to line everything up, which it actually is already lined up already, so we're okay. So I'm going to go ahead and write out the first matrix, which is the coefficients. First row is fine, 1, 1, 1, we're all good. But look at the second matrix closely. There's something missing. There's no z here. So if you're missing something, you have to be really careful. You're going to have to put a 0 in that spot, but it has to be in the space that it's missing. So if y were missing, I'd put the 0 in the middle. If x were missing, I'm going to put the 0 in the front. Since z is missing, whoops, let me put a 2 there, 2, 1, z is missing, I'm going to put the 0 here in the third position because that's where z is. It's the third letter. So just, you're going to put it wherever the position is that's missing something. And then the bottom row is 1, 3, negative 3. And then we're going to write the variables. They're in the order x, y, z, again as a column. And then that's equal to the answers, 2, 5, 14. My goal is to take this matrix and kick it over to the other side. In order to get it to move, I have to use its inverse. So we're going to get x, y, z is equal to 1, 1, 1, 2, 1, 0, 1, 3, negative 3. The inverse of that times 2, 5, 14. And then we're going to type that in the calculator. So I typed that in the calculator and we should get, I'm going to write it as an ordered triple right away. So the answer is 5 fourths, 5 halves, and negative 7 fourths. Okay? Alright, there is 2 problems for you to try on ClassKick just so I can see how you guys are doing with this. And then you have just a short homework assignment to do to practice this. Have a great rest of your day.